Okay, so this question is saying the diagram below represents a pendulum. So we have the length from the fixed support up to where the cotton thread or the string is ending. It is 10 centimeters, and then from where the string or the cotton thread is ending up to where the bob is ending at this point here, we are having 2 centimeters. Now, the question is saying the length of the pendulum is, meaning they are asking us to calculate the length of the pendulum. So feel free to pause the video and try to answer this one and compare with the answer that I'm going to give you. Okay, so of course, the first thing here that you are going to think of, you are going to add 10 centimeters plus 2 centimeters. Then the answer is going to be what? 12 centimeters. Now this one is wrong. This one is wrong. Apart from this one here, you're going to also to think of whereby you say the length is just from the fixed point up to where the cotton thread is ending, which is 10 centimeters. Even that one is going to be wrong. Okay, so if you have answered 12 centimeters or 10 centimeters, don't worry, those answers are not correct. So let me show you how to answer now this one here correctly. We are going to say from the fixed support up to where the cotton thread is ending, we have 10 centimeters, so we need to say 10 centimeters, then plus. Now these 2 centimeters here, we are not going to take the odd 2 centimeters, but what we are going to apply here, we are going to say every object has the center of mass. Every object has the center of mass. So this bob here, it has the center of mass at this point here, where the all masses appear to be concentrated. Now, if this one is having the center of mass here, and here we are having a 2 centimeter or 2 centimeters, meaning the center of mass is going to be at 1 centimeter. Now, how are we going to find that 1 centimeter? We are going to say half multiplied by 2 centimeter. So always, when you're finding the center of mass, you need to multiply by half. Whichever length that you have been given, whether 4 centimeters, whether 5 centimeters, you need to multiply by half if you want to find the center of mass. So what we are going to do here, we are going to say 10 centimeters, 10 centimeters, then plus. What is the half of 2 centimeters? That is 1 centimeter. Then from there now, what we are going to do is just going to add 10 centimeters plus 1 centimeter. Then the answer is going to be 11 centimeters. Meaning the answer here is just going to be what? C. That's the correct answer. To the next one. So the next one is saying, which of the following numbers has 3 significant figures? So in physics, when you're dealing with the significant figures, it's very, very important to remember the rules. So if you have a number like 0.03, one thing that you need to know here is that the zeros on the left side, we consider them to be significant figures, meaning this 0 here and this one here, they are going to be all significant figures. Meaning how many significant figures do we have here? We can say we have 1, 2, 3. So here we have 3 significant figures. But when it comes to the zeros on the right hand side, which are not covered by the whole number, they are not significant figures. An example, if we have 0.200, how many significant figures do we have here? We only have 2 significant figures, because I'm from saying that zeros on the left hand side, we consider them to be significant figures, meaning this one is going to be the significant figure, even this 2 here is going to be the significant figure. But the zeros on the right hand side, which are not covered by the whole number, they are not significant figures. Meaning these 2 zeros, they are not significant figures. Here we only have 2 significant figures. Apart from that one, if we also have 0.102, how many significant figures do we have here? So try to pause the video and find how many significant figures do we have here. Okay, so this 0 here on the right hand side, it is covered by the whole number, meaning it is going to be the significant figure, unless it is not covered by the whole number. So how many significant figures do we have here? So we have 1, 2, 3, 4. So we have 4 significant figures. Now, this question is asking us to find the number which has 3 significant figures here. So if we try to look at the first one, which is option A, how many significant figures does option A has? So it has how many? It has about 5 significant figures, because I'm saying zeros on the left hand side, we consider them to be significant figures. Then when it comes to option B, how many significant figures do we have here? So we have 1, 2, 3, 4. So we have 4 significant figures. Now this question is asking us to find 3 significant figures. About option C. So option C, it is having how many significant figures? 3 significant figures, because I'm from saying that zeros on the right hand side, we don't consider them to be significant figures. Meaning how many significance? We have this one here, which is 1, 2, 3. And these 2 zeros, they are not significant figures. Then option D, of course, it has 2 significant figures, meaning the answer is going to be C. The next question. Okay, so the next question is saying, a body has a mass of 2 kgs. It accelerates from 20 meters per second to 40 meters per second in 4 seconds. The resultant force is, so here they are asking us to find the resultant force. So we need to write the formula for the resultant force. So force is equal to mass multiplied by acceleration. Now according to the data that we have here, we have the mass, which is 2 kgs. Apart from the mass, which is 2 kgs, we also have the initial velocity, which is 20 meters per second. Then apart from the initial velocity, we also have the final velocity, which is 40 meters per second. Then the last one we have also the time, which is 4 seconds. Now, this question is asking us to calculate the resultant force. When you're calculating the resultant force, the first thing you need to have the mass. And the mass here, we already have the mass. Then apart from the mass, we need also to have the acceleration of an object. Now, do we have the acceleration of an object here? No, we don't have. So there is a need for us to find the acceleration. Now, as a physicist, you need to know that acceleration is equal to final velocity minus initial velocity divided by time. Meaning where we are having acceleration here, we can replace acceleration with these quantities here, that is final velocity minus initial velocity divided by time. So if you don't want to do that, you can just find the acceleration, then you input the acceleration where we are having A. Okay, so let's do that. So we are going to say acceleration is going to be equal to final velocity here is 40 meters per second minus the initial velocity, which is 20 meters per second divided by 4 seconds. So we can say 40 meters per second minus 20 meters per second, we are going to get 20 meters per second divided by 4 seconds. Then the answer, when I divide, it is going to be 5 meters per second squared. So here the acceleration is measured in meters per second squared. So this one is our acceleration that we are going to use. So let's try to find now the resultant force. So we can say the resultant force is going to be equal to the mass here. The mass here, it is 2 kgs multiplied by the acceleration, which is 5 meters per second squared. Then when I multiply, I'm going to get the answer, which is 10. Now specifically it is 10 newtons, because the resultant force, or the force, is measured in newtons. As a result, the answer is going to be B. The next question. So the next question is saying, the figure below shows an ideal pulley system. So an ideal pulley system produces the efficiency, which is 100% efficiency. An ideal pulley system produces 100% efficiency. Now, one thing that you need to know here is that when a pulley system is an ideal, or it is producing 100% as the efficiency, you are going to find that the mechanical advantage is going to be equal to the velocity ratio. This one is only applicable when the pulley system is an ideal, or it is producing the efficiency, which is 100%. So I'm saying when the pulley system is an ideal, mechanical advantage is equal to the velocity ratio. Okay. So assuming G, which is the action due to gravity, is 10 meters per second squared, we need to find the minimum effort required to raise the load is. So now we know that mechanical advantage is equal to load over effort. So we have load over effort. Then apart from that one, velocity ratio is equal to effort over load. So we have effort over load. Now, apart from this one here, from this question we have been given the load. Now this load here, it is in kgs. Usually the load should be in newtons. That's the reason why they have given us this one here, which is G, to assume G as 10 meters per second squared. So we can calculate the weight, which is the load. So we can say weight is going to be equal to mass multiplied by gravity. So the mass that we have here, it is 5 kgs. Then the action due to gravity that we have, it is 10 meters per second squared. So when I multiply, the weight or the load is going to be equal to 50 newtons. So that is how we find the load of an object. And then apart from that one, we need to calculate now the velocity ratio. Now from saying that if the pulley system is an ideal, it is going to produce the 100% efficiency. Therefore, mechanical advantage is going to be equal to the velocity ratio. So, how do we find the velocity ratio using the pulley system? We count the number of wheels. So, how many wheels do we have here? So, we have 1, 2, 3, 4, 5. So, here we can say the velocity ratio is going to be equal to 5, and also the mechanical advantage is going to be equal to 5. Now, apart from counting the number of wheels, you can also count the number of loops at this point here. You're going to find that the answer is just going to be the same. If you just count the number of loops that we have at this point here, the answer is just going to be the same. Now, which formula here are we going to use to calculate now the minimum effort which was used to raise this load here, which is 50 newtons? Which formula are we going to use? Are we going to use mechanical advantage, or we are going to use velocity ratio? Feel free to pause the video and try out to answer this one. Of course, here we are going to use the formula for finding the mechanical advantage. So you know that mechanical advantage is equal to load divided by effort. So what is our mechanical advantage? Our mechanical advantage, it is 5, because I'm from saying that if the pulley system is an ideal, mechanical advantage is going to be equal to the velocity ratio. Okay? So we can say mechanical advantage, which is 5, is equal to the load. So what was the load? Our load was 50 newtons divided by the effort that we don't have. So here I can multiply. So E, which is the effort, multiplied by 5, we are going to get 5E, which is the effort, being equal to 1 multiplied by 50 newtons, we are going to get 50 newtons. When I divide by 5, even here by 5, the effort, which is E, is going to be equal to, so 5 into 50 newtons, we are going to get 10 newtons. So our answer here is just going to be D. So that was the last one. Thanks for watching, and if you're new to this channel, subscribe for more videos like this.